Hi everyone. This is a video over chapter 4, lesson 3, called Congruent Triangles. So what we're going to take a look at today is basically how to tell if two triangles are congruent, meaning exactly the same, okay? So the first thing we're going to look at are two triangles and their angles. So let's say I've got two triangles right here. If I said that these two angles were the same and these two angles were the same, what is your, what would be your assumption about these angles right here? I would assume that they would be the same. Now let's call this ABD and this one CEF. Let's kind of play with some numbers and put in some values and see if that makes sense, okay? So let's say angle A is 45 degrees. Maybe let's say 40, okay? Angle B is 50 degrees, all right? Now, the triangle angle sum theorem basically tells us all the angles added together have to equal 180 degrees. So if I were looking for angle D, then I know that that's 180 minus 40 minus 50, right? Which leaves me with 90 degrees. So angle D is 90 degrees. All right, so we just found angle D, okay? If I knew angle A and angle C were the same, that means angle C would have to be 40 degrees. If I knew angle B and angle E were the same, I would have to say that they're the same measurement, which is 50. And so if I'm calculating the final angle, angle F, well, following the same methods of the triangle angle sum theorem, 180 minus 40 minus 50 will also equal 90 degrees. So therefore, if what we realize is if we only know two angles are the same, we can also conclude that the third angle will also be congruent. And if the third angle is congruent, then I believe we can say that these, I guess, all angles are congruent to each other, or yeah, that this triangle is congruent or the angles are congruent to each other. So let's take a look at our study guide. The first thing we're going to do is basically identify what's the same on our study guide. And I believe this is the study guide here. So the first thing we're going to look at is just naming what is congruent to each other by naming the sides and the angles, okay? So it's really nice when we can see they're in the same position. We could say angle A is congruent to angle J. They're in the same spot. Angle B is congruent to angle K. And angle C is congruent to angle L. All right. Now, if I'm looking at sides, I would say AB is congruent to JK. And remember, I'm going to name them by the position they're in. So if I say A first, I would have to then say J first and then K. If I say AB and then KJ, I'm flip-flopping the position of that side, and that would be wrong. So make sure the position that they're in is also correct. Now, if I say BC is congruent, which one would be congruent to? Be congruent to KL, right? Because B and K are in the same spot. So KL. And then finally, AC is congruent to JL. So those are congruent there. Okay, now number 2, these are flipped. So we really need to take notice of the markings on our drawing and also be able to kind of correspond which parts are connected to which parts. So A has one little mark, D has one little mark. So angle A is congruent to angle D. C has 3 marks. This has 3 marks, except for I can't name this angle C because that would be like everything in here, and everything in here, there's 2 angles. So I'm going to have to name it by 3 vertices. So ACB, you would say ACB is congruent to DCB. Does that make sense? So I'd have to say D first, DCB, because I started with ACB. A is in the same spot as, like, that's like the corresponding side to where D is. And so I'd have to say angle DCB. And then finally, I have this angle here. So ABC is congruent to DBC. All right, now let's look at the sides. Now the sides, this has one mark. So I'm going to say AC is congruent to DB. All right, D is where A is, right? Those are in the corresponding spots. Now if I say BC is where CB is. So I have to kind of think through what that would be if they're flip-flopped, right? CB. And then my third side that I'm looking at, AC, BC, and then AB, right? Let's say AB. AB is congruent to DB. Okay, you have to imagine having to flip one of these triangles over and then placing them on top of each other and thinking what's corresponding to what. Let's do 3 and then maybe 6, and I'll just do those 2. You probably want to practice these other ones just to get an idea of what you're looking at, okay? So here I've got a right angle, it looks like, and here's a right angle. So J and L are kind of corresponding. J congruent to L. Angle K, it's not congruent to this angle here. It's like this opposite one, right? These two. You can even think of like alternate interior angles, right? So K, and this isn't going to be named K because that would be not very clear of what it is. So we would say angle JKM maybe. JKM is congruent to MLK, or no, JKM, let's say K. It would be, yeah, LMK, perfect, LMK. And then saying this JMK, JMK would be congruent to LKM. Okay, so when I look at this, I can tell J and L in the same position, K and M same position, M and K same position. So they're corresponding, right? J and L, K and M, M and K. All right, so now for the sides. Well, KJ, probably corresponding to ML. And then JM, corresponding to LK. And then this middle one, KM, is corresponding to MK. Think of it having to be flipped over and placed on top of each other, right? So MK. Okay, let's do 6. So again, we've got, think of this as mirrored. So if I folded it, I guess T would be congruent to R, angle R. And then angle, this right here is corresponding to this angle. So RUS congruent to TUS. And then finally RSU corresponding to TSU. Okay, sides. RS congruent to TS. Bottom side RU congruent to TU. And then the middle one, so SU, actually I would say would be the same, right? SU and SU, same spot, because I'm not flipping anything over. So on your homework, this is what I'm looking for. It's just identifying what parts are corresponding and congruent to each other. You need to label all the angles and all the sides. All right, so let's take a look here. If I know that these are congruent triangles, then I know that B is probably where E is, A is where D is, and then C is where F is. Okay, so if I just kind of turn this a little bit down. And if they're the same, if they're congruent, then I know all the sides have to be equal as well. So looking at this, if angle D is 2y minus 5, and this angle is 65, well, I could set them up as equal to each other to find it. So then when I add 5 on both sides, I have 70. 2y equals 7. 2y divided by 70 is 35. And so y equals 35. So I found y. Now to find x, we know EF would be congruent to BC. So I need to set it up as the same part, right? So 90.6 equals 2x plus y. All right, now, so because I found y, I can do this. If I hadn't found y, I wouldn't be able to work this out. So 2x plus 35, let's plug in what we just found. Now I'm going to subtract 35 from both sides. So I've got 0.4 here. And then this would be 56, right? 56. And then I have 2x. So divide on both sides. That would be 28.2 is the answer for x. I believe. Let me just double check that. So I did that all in my head. 90.6 minus 35. Oh, it's 55.6. Oh, I don't know what I was thinking. All right, so 55.6 divided by 2. So the answer is actually 27.8. When math teachers make mistakes, right? All right, so when we are looking at triangles and trying to decide if they're congruent or not, one thing that we need to look for is that the parts of the triangle are congruent to each other. So if I had this triangle, I copied it and pasted it. Sadly, I don't have that feature here. And all my angles are equal. And all my sides are equal. They're corresponding and congruent. These two are the same. These two are the same. These two are the same. We can now say that these two triangles are completely congruent to each other. And so to prove that two triangles are completely congruent, they're exact same size and exact same measures, we would have to see that all the parts are congruent. So we've actually come up with a theorem that describes this, and that is called, well, it's not really a theorem, I guess. It's just a saying. It's a phrase. We know that if all the sides and all the angles are congruent, then I can say all the two triangles are congruent. So I'm going to write this down right here. If all angles and all sides of a triangle are congruent to each other, then I could say, so remember this little thing means then. Ooh. Then, right? The two triangles are congruent. And that's all. So to sum up all of this, I don't want to have to write that every time, right? I don't want to have to write this whole saying every time. So to sum that up, I'm going to say corresponding parts of corresponding triangles are congruent. So this stands for, I'm going to type that actually. I'm going to type it there. Equals corresponding parts, let me capitalize it, parts of corresponding triangles are congruent. Sorry, corresponding parts of congruent triangles. Where is it at? Let's write that again. Corresponding parts of congruent triangles are congruent. Okay, so really what that's saying is, if all the corresponding parts of the triangles are congruent, then the triangles are congruent. So now we can use that in our proof. So basically, if in my proof, if I can somehow say that, here's my little thing here it is. If I can say like these two are the same, these two are the same, these two are the same, and then these two are the same, these two sides are the same, and then these two sides are the same of these two triangles, then I could say these two triangles are completely congruent. So I have to name all the parts and all the sides, like all the angles and all the sides, and say that they're all congruent and corresponding. Then I can say that those are congruent. So let's do this proof. That is our example proof on our notes first, just to practice kind of writing down some proofs with knowing what the information is and what the answer is, because I think that can kind of help us think through the process of it. So I'm going to draw a picture, I guess. So the picture on your study guide, you've got a picture. I would draw this in your notes too. And if you draw a picture in your homework for your proofs here, if you draw the picture down, I will give you extra credit for the drawing, because I think it's a great habit to list out the information and draw it, because as you're drawing, you're making connections of what's going on. So the given is that you've got all these sides that are congruent, and you have it in your notes there. And then you've got these angles that are congruent. Angle BAD is congruent to angle BCD. And then it says BD bisects. Now, this is an interesting word that we've looked at before. Bisects. What does it mean to bisect something? So as you're reading through this given, you've got to think through, well, what does this all mean? What does the word bisect mean? And if you don't know what the word bisect means, how can you even keep going? Because you can't conclude anything from that statement. So just to review, if I've got an angle bisector, if I've got a bisector, that means I've got an angle here. Let's say this is A, B, C, and BD is bisecting it. Here would be D. It's bisecting, meaning it's cutting these two angles into two equal parts. So these two angles would be the same. So let's do this proof together. I'm going to set up a 2-column proof. Maybe I'll use different color here. So here's my 2 columns. And of course, I've got my statements and my reasons. Statement and reason. And I'm just going to list out my given. And I might just start with some of my sides first. So like if I looked, AB and CB are congruent. So AB is congruent to CB, that's given. And then AD is congruent to CD. So that's given. And let me look at what's going on. So I'm going to mark it on my picture. AB and CB, those are congruent. And then AD and CD are congruent. Now I need to prove just one more thing. If I can prove that this side right here is congruent, then I am good to go on naming all the sides being congruent. And so my goal is to name that all sides are congruent. These are my goals right here. All sides are congruent. And I also want to name that all angles are congruent. And if I can do that, then I can say CPCTC, corresponding parts of congruent triangles are congruent, meaning that the two triangles will be congruent. So what do I notice here? This side is overlapping with itself. So if I say BD is congruent to BD, the same side is congruent to itself, right? It's just the same side. These two triangles share the same side. Well, anytime you say something is congruent to itself or equals to itself, that's what we call the reflexive property. And so we learned this a little while ago. We're going to now make use of it, reflexive property. So we've checked off all the sides being congruent. Look, I drew them on there. Now let's take a look at angles being congruent. So in our given, we've got angle BAD is congruent to BCD, and that's given. And then, so I'm going to draw that BAD. So that's right here. is congruent to BCD. So that's right here. These two sides are congruent, okay? Um, now the information given to me is that BD bisects ABC. So BD bisects ABC. That's also given. So that's given there. Well, remember what we talked about bisectors? If I have this line, this BD, bisecting through ABC, which is this angle, then it cuts it into two equal parts. So if it cuts it into two equal parts, I can conclude that this angle here and this angle here should be the same. And that's because I know what a bisector is. If I didn't know what a bisector is, I wouldn't be able to conclude that. So I'm going to say that angle ABD is congruent to angle CBD. I'm saying ABD right here is congruent to CBD right here. And that is because of the definition of an angle bisector. And I only know this because of this piece of information. I only know that they're the same because I know what a bisector is, and it was stated that there was a bisector. So now I've covered like all these angles here. These two are the same. I'm missing this angle. But didn't we just learn earlier that if two angles are the same, then the third angle should also be the same? And actually there's a theorem, I totally forgot to mention it. It was on your study guide, but it's called the third angles theorem. So you might want to write that down. The third angles theorem. That's saying that if two angles are equal, are corresponding and congruent, the third angle will also be corresponding. The third corresponding angle will be congruent. So, so now I can say, well, I'm going to conclude that ADB is congruent to CDB. And that's because of the third angles, third angles theorem. Ooh, I'm running out of room here. So now I can say, because I've proven all my sides that are corresponding are congruent and all my angles that are corresponding are congruent, I'm going to say these triangles ABD is congruent to CBD, triangle CBD, because of corresponding parts of congruent triangles are congruent. So if I have two triangles that have all the corresponding parts and they're congruent, then the triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay, all right. Now let's take a look at one of our proofs on the study guide. So let's take a look at the ones where we have to fill in the blank, okay? So we're left with this. Oh, there's two of them. So let's take a look at this here. First things is to mark the information that you see, because it's going to help you narrow down what you're missing, okay? So A and C are congruent. I'm going to mark these as congruent. D and B are congruent. D and B are congruent. I'm going to use different markings. And then I'm not stated that this angle here is congruent. But what do you notice? These are called vertical angles, right? So if I know vertical angles, they're vertical angles, then they have to be congruent. So that might be something I would state later on. But right now, it's not given to me. So I'm not going to worry about it just yet. Now looking at the sides, AD is right here. It's congruent to CB. So those are congruent. And then AE is congruent to CE. Oh, and then it says AC bisects AC bisects BD. Now we've got bisectors of sides, like where if you have this, like let's say that this is AC and then BD is bisecting, so B and D is bisecting, it's cutting through this, then what we conclude is that the two parts being bisected by a side are going to be congruent. So this part here, A to this, is congruent to C to the center where they're cut. Okay, so that is the definition of a bisector, I think just like a regular segment bisector, because this is segment here. I was blanking for a second. So and we're trying to prove the triangles are congruent. So that basically means if I can conclude that these, let's put what I'm trying to get in yellow. That's what I'm missing. So if I can somehow say that these are the same, and I can somehow say that these are the same, then I'm set and I can use CP/CTC to say these two triangles are congruent. So let's just start by writing down our information, statements and reasons. And we're going to start with our angles. A is congruent to C, and D is congruent to B. That's given. And I know that these angles, AED and BEC, are congruent because they're vertical angles. So anytime you see vertical angles, you don't really have to say too much. AED is congruent to CEB. So definition of vertical angles. Okay, so now we're looking at the sides. So if I list out all our givens, we've got AD is congruent to CB, and we've got AE is congruent to CE. So I know that because of my givens. So again, I need to somehow prove that these two sides are congruent. Now, that can be explained if I know what a segment bisector is. So because I know that AC bisects BD, which this example actually, BD is the bisector, but in this case, AC is bisecting, is cutting through DB, which means these sides have to be the same. So I'm going to say, and I'm actually probably going to state my given here. I want to state all my given, bisects BD. Okay, now because of this statement, so let me separate these out. I know it's kind of squished, but that's all some statements here. Okay, now I'm going to say that DE is congruent to BE, and that's because of the definition of a segment bisector. So I can come up with this conclusion because of this given right here. I'm coming up with that conclusion. Now I've stated that all my corresponding sides are congruent, all my corresponding angles are congruent. So now I can say triangle AED is congruent to triangle CEB, and that's because corresponding parts of congruent triangles are congruent, CP/CTC. You're going to know that really well by the end of this chapter here. All right, see if you can do this last one by yourself. I'm not going to do it with you. I might do a video later to work that out. And anytime you see paragraph proofs in your homework or on your lessons, just do it as a 2-column proof, unless you want to write everything out. But to me, it really doesn't matter that you're writing it as a paragraph proof. I think it's a little more simple to write it as a 2-column proof anyway, and it's the same logic. So just write it as a 2-column proof.